Welcome back. We're on page 91 and we're looking at question 31. So let's dive straight in and see how we go. Right, we're finding inverse functions. Remember the steps. It's a real step-by-step process here. First thing we do is we write it as y equals. So y equals 3x minus 5. Then we swap x and y around. X is 3y minus 5. Next up, we solve for y. We make y the subject of the formula. Let's add 5 to both sides. And let's divide both sides by 3. Right, so y is going to be x plus 5 over 3. But lastly, we write it as f inverse of x equals x plus 5 over 3. Let's just check, as we love to do. Let's check if we put 2 in here. 3 lots of 2, 6 minus 5, we get 1 out. Let's check if we put 1 into this inverse. 1 plus 5 is 6. 6 over 3 is 2. Hala la. Right, the next one's an exponential one, but the process is exactly the same. We start off, we write it as y equals 2 times 3 to the x plus 6. Next thing we do is we swap x and y around. X is 2 times 3 to the y plus 6. Now we want to make y the subject of the formula. Let's subtract 6 from both sides and then let's divide by 2. So x minus 6 over 2 equals 3 to the y. We want to get y on its own. The way we get something out of an exponent is we put it into log form. Y equals log base 3 x minus 6 over 2. Okay, and the very last thing we're going to do is we're going to write it as f inverse of x is log base 3 x minus 6 over 2. And just like we did last time, let's check that. All right, let's put a number in here. Let's put 1 in here. If we put 1 in here, 3 to the 1 is 3. 2 times 3 is 6. We actually get 12 out. Let's put 12 in here. If we put 12 in here, we get 12 minus 6 is 6. 6 over 2 is 3. We get log base 3 of 3. What power must we put onto 3 to get 3? The answer is 1. Okay. Right. The next one is actually 4 more. If you haven't tried them, pause the video. If you have tried them, let it play. All right. Make sure you've tried them before you watch us doing them. Excuse me. First step, we're going to let f of x be y. So y equals negative 3 over x minus 4 plus 5. We're going to swap x and y around. X is negative 3 over y minus 4 plus 5. Now we're going to get y on its own. Let's subtract 5 from both sides. So x minus 5 equals negative 3 over y minus 4. We're going to multiply both sides by y minus 4. So we're going to get y minus 4 equals negative 3. Y minus 4 times by x minus 5. It's negative 3. Now we're going to divide both sides by x minus 5. And that's going to leave us with y minus 4 here. Right? And then we're going to add 4 to both sides. I'm going to do quite a lot in one go here. I'm also going to write it as f inverse of x. So I'm going to divide both sides by x minus 5. Right? And then I'm going to add 4. Okay, let's check as we did with the other ones. All right? If we were to put, say, 4 in here, not 4 in here, let's put 5 in here. If we put 5 in here, we're going to get 1 on the denominator. So we're going to get negative 3 plus 5. We're going to get 2. Right. When we put 5 in here, we get 2 out. Let's put 2 in here. and see what we get out. Well, we're going to get negative 3 on the denominator. Negative 3 over negative 3 is positive 1 plus 4 is 5. Okay, it definitely seems to be right. The next one is a log graph. Okay, the inverse should be an exponential function. But let's see how we're going to find it. We're going to go y equals log base 2 x plus 3 minus 5. We're going to swap x and y around. X is log base 2 y plus 3 minus 5. Now we're going to get y on its own. We're going to add 5 to both sides. So x plus 5 is log base 2 of y plus 3. We're now going to take it out of log form into exponent form. So y plus 3 will equal 2 to the x plus 5. The last thing we're going to do is we're going to subtract 3 from both sides, but I'm also not going to write it as y, I'm going to write it as f inverse of x equals 2 to the x plus 5 minus 3. Okay, let's check that. Okay, if we were to put, let's say x was 5, and the reason I'm choosing 5 is I'll get 8 in here. And if I get 8 in here, what power must I put onto 2 to get 8? Well, the answer is 3. And 3 minus 5 is negative 2. So 5, negative 2 lies on this thing. Okay? Now let's see if I put negative 2 into here. Negative 2, I'm going to get 2 to the power of 3, which is 8. 8 minus 3 is 5. Negative 2, 5. Okay, the next two involve domain restrictions. Okay, and so let's just remind ourselves what's going to happen here, because this is a parabola. Okay, and it's many to 1. It's many to 1. When we find the inverse, we're going to get a non-function because we're going to get 1 to many for both E and for F. Right, let's just continue as normal for now. But what we're going to do is we're going to only take half of this parabola. Suppose we say x bigger than or equal to 0. So we are only taking the right-hand branch of the parabola. If we had to picture this, we're taking x squared minus 4. It's a parabola, positive, happy parabola. It's been dropped down by 4, but we're only going to take that branch. Okay? And I want you to look at the domain of that would be x bigger than or equal to 0, and the range of that would be y bigger than or equal to negative 4. Now let's find the inverse, exactly as we did before. Y equals x squared minus 4. Swap x and y around. X is y squared minus 4. Solve for y, so we can add 4 to both sides. X plus 4 is y squared. And now we're going to square root. But when we square root, we're either going to have positive or negative. And we've just got to think as to which that's going to be. Right. So think about the domain of this was positive values only. So the range of this must be positive values only. And there's our answer. It's not quite our answer, in fact, because we should write it as f inverse of x. F inverse of x equals the square root of x plus 4. We could have chosen the other half of the parabola. If we'd chosen the negative branch, then we'd have a negative in here. Okay, if we'd chosen the bit on the left-hand side of the y-axis. Okay, let's, as we've always done, let's just check a value here. If we put 2 into this function, we get this point over here, 2, 0. 2, 0 lies on the function. If we put 0 in here, the square root of 0 plus 4 is square root of 4, 2. Okay, and then the very last one, and maybe you didn't know how to do that. If not, and you want to check yourself, pause it and try this one yourself before letting the video play again. All right, but this one is going to be also a parabola, but now notice that this one is something like this. This is a sad parabola, kind of upside down, concave down, like that. Okay, what we're going to do this time, we will just take this half. Okay, so in other words, we're not going to take that half. We're going to just say x less than or equal to 0. Okay, so let's now work out how we're going to do this. We're going to write this as y equals negative x squared plus 5. We're going to swap x and y around. We are going to solve for y, so we're going to get y squared is negative x minus 5. Sorry, y squared is negative x plus 5. Alright, if we add y squared to both sides and subtract x from both sides. And so we're going to get y equals. Now, we're going to have, when we square root, we're going to have either the positive or the negative. Alright, and we want to think about what was the domain of the original function. Well, the domain of the original function was negative values, so the range of the inverse must be negative values. So this is going to be f of x equals the negative square root of negative x plus 5. Okay, and so if we look, let's just test a point as we've done with all the others. If we put 0 into here, we get 5 out. 0, 5. Let's try putting 5 in here. Now, if x is 5, we're going to get 0 out. 5, 0. Okay. And remember, the reason that we need to restrict the domain is because it's a many-to-one function. It passes a vertical line test, but it fails a horizontal line test. All right. We're going to now look at this question over here. And this is a fairly standard idea where we work out the length of a line. Right? We've got a vertical line here. Now, if we suppose this x value is x, okay, then the y value of this point is 2x squared minus 3x minus 7. And that's because this point lies on this parabola. Every single point that lies on this parabola has that relationship between its x's and its y's. If we take a specific value, for example, suppose x was 1, then our y value would be 2 lots of 1 squared minus 3 lots of 1 minus 7. If x was 0, our y value would be 2 lots of 0 squared minus 3 lots of 0 minus 7. If this is x, then this value here is also x because this is a vertical line. Okay, it says vertical line. Right, so they've got the same x values. Okay, and so this point over here will also be x, but it will have a y value of negative x squared plus 5x plus 6, and that's because it lies on the function f, negative x squared plus 5x plus 6. Okay, now I just want to show you that the length of a vertical line will just be the difference in the y values. Okay, suppose we had this point over here, which would be an easy point to work out. This point would be 6, and this point here would be negative 7. If we just take the bigger y value minus the smaller y value, 6 subtract negative 7, these graphs are 13 units apart at that point. Okay, so the length of AB is just going to be our bigger y value minus our smaller y value. So that's going to be that minus the smaller y value is 2x squared minus 3x minus 7. Okay, now let's do this subtraction. And what we're going to get negative x squared minus 2x squared. We're going to get negative 3x squared. We've got 5x, and we've got minus 3x. We've got 8x. And we've got 6, and we've got plus 7. We've got 13. Okay, and we want to know where is that at a maximum. Now this, if we picture this as a graph, it's actually a graph that goes like that. Okay, and we want to find out what its maximum length is. There's two ways of doing this, all right? One of them is to use our axis of symmetry formula, our x equals minus b over 2a. But what we're going to do is we're actually going to try and write this in a completed square form. Okay, so we're going to write x squared here. This is going to be minus 8 over 3, lots of x. And this is going to be minus 13 over 3. Okay, next up we are going to try and write this as negative 3. And we're going to try and write it as something squared. Okay, when we square this out, we are going to get whatever we put here is going to multiply with the x and then double. So we need to halve that value. All right, so x minus 4 over 3 all squared gives us that. X squared minus 2 lots of 4 over 3, that's 8 over 3. The way I got this is I halved that. But we're also going to end up here adding in 16 over 9. And that 16 over 9 we didn't have. So we need to subtract 16 over 9. Okay, and now that is actually, if we can do this on a calculator, we shouldn't need to. This is going to become negative 39 over 9, right? If I change this into nines, minus 55 over 9. When I multiply the minus 3 back in, I'm actually going to get this. I'm going to get 55 over 3. Okay, now that is the length. And what we can see is that that number will always be less than or equal to 55 over 3. This here is the maximum value that that can ever have. And the reason for that is that when we square something, do you agree that this piece so far is always positive? All right, that's always positive. But when you multiply it by negative 3, it's always negative. So we are always going to be subtracting from 55 over 3 unless x is 4/3. And if x is 4/3, then we will get 55 over 3. So this here is the maximum length. And that maximum length occurs when x is 4/3. So somewhere over here, when x is 4/3, wherever that is, that'll be the maximum length. Now 55 over 3 is a bit bigger than 18. And remember we said this length over here was 13. So it gets a little bit longer as we move across. Okay. All right, the next question, and in fact we're going to stop there and we'll try the next question in the next lesson, but we'll give you a little hint for the next question. And that is that when a graph moves, its axes of symmetry move as well. So we're going to look at this question in the next lesson, and we're going to show you two different ways of thinking about it, which will lead to the same one. So we look forward to seeing you then.